For those of you that don't know me, or haven't heard about me, shame. Okay. Apparently, I'm a good person to know. But my name is Sarel van Greenen, aka Mr. VG. And if you've watched a lot of the videos on the Junior Tux channel, you would have, my voice would be very, very familiar. Okay. Sometimes I realize after doing about 5 videos, and you realize I've got no clue what just happened in the previous 4. So I hope that they helped you guys and that they are going to help you guys. But welcome to the madness of mathematics, okay? Today, as you can see on the board, I am going to do just probabilities for 2 reasons. Number 1, you guys suck at it, okay? Secondly, my experience is most teachers suck at it, okay? Because, and I'm always on the teacher's side of this, that you've got to understand, teachers that did not do maths with the new curriculum, what you guys are doing, most probably for the first time saw probabilities when they had to teach it. Because it was not even in my curriculum when I did it, and I only did matric, what, Chris, 21 years ago? We're getting old, hey? 21 years ago, I was sitting where you guys are seated, although we were not as blessed to have these kind of presentations, but we didn't do probabilities. I did probabilities at varsity because I decided I'm never going to become a teacher in my life. That didn't go very far. I said I want to become an actuary, and I studied to become an actuary, and I finished my degree, and I realized that ain't for me. So one thing that I do want to just quickly stress is, let's please have respect for one another. So switch off your cell phones, okay? Or at least, because I know some of you have serious FOMO, okay? Serious FOMO. Just at least switch your cell phone to airplane mode, okay? But say, why not silent? Because if your mom is really anxious because she hasn't seen her baby for 2 whole hours, okay, and she rings more than twice, it goes on to ring automatically. If you didn't know that, now you know it. Okay, so please switch your cell phone on airplane or off completely. I promise you it's going to be worth it. Okay, it's going to be worth it. Today we're going to do probabilities, and I have decided that I am still on holiday. For those of you that don't believe me, I literally arrived back from Durban 1 hour and 20 minutes ago. So I'm still on holiday. So a lot of today's presentation is you guys are going to do the work. But of course, I'm going to help you guys every now and again, okay? But the nice thing is, and this is the important thing, is you are not alone. You've got friends around you. So I want you guys, I'm going to put up some questions out of the past 2 to 3 years exam papers. So some of it's going to be familiar, some of it you might never have seen. But I'm also going to just talk through your approach to the sums. Because right now, you guys have, most of you would have written 2 exams. June exam, which went horrible. Okay, it's just the way that June exams go. Then you realized how much you suck at maths. Then you went back to the June holidays, and then you tried a bit more. Some of you attended the Junior Tux Winter School, which I'm seeing some familiar faces. And then you went and you wrote the prelim exam, and you feel a little bit better about maths. And now you are here and you're realizing there's some small chapters, some of you bigger chapters than others, where you still suck at. And that is all right. That is all right. Because 75% of your marks is going to happen in the next 8 weeks. Let that just quickly sink in. That is the gravitas of the next 8 weeks in your life. Whatever you've done so far, 12 years have passed, 12 years of good times, bad times, 12 years of highs and lows, COVID and everything, is building up to the next 8 weeks. 75% of your marks is still lying ahead of you. Good or bad. But for you guys sitting here, I believe it's going to be good. So I am encouraging you. You have one of three options. You can either sit back in your chair, I got this, and you kind of just doodle for the next 2 hours, and you kind of just go, meh, whatever this guy's saying, I'm all right. Or you can play around, which hopefully none of you are going to do. You can just punch your friend. Oh, did you see what that guy was wearing during lunchtime? Or did you see that girl's makeup? Oh my goodness. Or hopefully the third one is you'll be sitting like you are sitting. Leaning in. Making the decision. Even though you might have gotten 100% for the prelim for this, you've got no clue what's coming up in the finals. The same with the attitude towards the physics coming later. Okay? So, let's quickly just go through probabilities, because this is the very important thing that you kind of have to understand. If you look at probabilities, you are going to get two types of sums, and they are cleverly disguised, although they're quite easy to distinguish. When we're talking about grade 11 sums, okay, that is the sums before you did codes and you did the factorials and all of those things. So it's tree diagrams. I put that up first because that's one that you guys really did not do well in. Then contingency tables you guys are quite good with. Venn diagrams. Those are your three basic types of grade 11 sums. Which other things do you need to be able to apply inside everything else? Independence, mutual exclusivity, and then probability sums. Okay, so let's just quickly do a little bit of theory. Little bit. Small nyana theory. I mean, it's one of school, so I always do just a small nyana of everything. Let's quickly talk, ladies and gentlemen, about those three things. Independence, mutual exclusivity, and probability sums. So when we talk about this, let's just make sure everyone is on the same page. What is independence? Who's willing to put their whole reputation on the line? Or just say something? Okay, you're willing to say something. Yes. What do you say? What is your name, first of all? Danny. And what is independence?
Independence in this context is when the probability of events happening is not dependent on the probability of another event happening.
Okay.
And they don't have anything to do with each other.
Okay. I wish you didn't put that last little bit of a sentence in it. But, okay, just ignore it, just brain fog, it's all right. Okay. You are on the right path. I really love it. But I do just want to quickly just ask you to be careful because the university's professors are very clever. Okay? In your mind, it must be the outcome of one event has got no effect on the outcome of the next event. That's what independence means. So when we talk about, I'm going to write bigger, my apologies, independence is if I look at outcome 1 and I look at outcome 2, they do not affect one another. So, sir, good luck with being independent from your parents one day. None of you will ever reach that. Oh, yes, that's the truth. Because if your dad, for instance, decides to date a lovely young lady that is younger than you, it is going to affect you, okay? You will never really be independent, okay? But this is the psychological or the funky way of thinking about independence. But be careful. Independence, mathematically speaking, is simply that the probability that A and B happens is the probability of A times by the probability of B. That is it. But, sir, the university professors are really clever with this. They give you two outcomes that say this one has to affect. They say, Did you prove that? Yes. Then it's independent. No matter how you feel about it, that's why I love maths. Doesn't matter how I feel, that must be true. Okay? So a very important little thing, words matter. Don't be blasé about words. When you read the word independence, the first thing I think of is this. Nothing else. I don't think about does one affect the other one? No. I think about this, and as an afterthought, I think of, but what does it really mean? Now, what is mutual exclusivity? Yes? What's your name? Tapelo, yes?
The mutual exclusive is when the probability of one event doesn't affect the other event.
That is independence. Kind of be careful. Yes, sir. What's your name? Ndumiso. What do you say? What is mutual exclusivity?
It's the impossibility of two events occurring at the same time.
Oh, I love that. An impossibility that two events can occur at the same time. Okay? Well done, sir. Two events cannot happen at the same time. It cannot be day and night at the same time. It's one or the other. It cannot be raining and not raining at the same time. You can't be first and second at the same time. Things that don't happen at the same time. So in other words, when I talk about mutual exclusivity, okay, are there any Afrikaans students that do maths in Afrikaans? Okay. Onderling uitsluitend. Okay. So are you the only Afrikaans guy, the only Afrikaans person, another one there? Okay. Onafhanklikheid en onderling uitsluitend. Okay. Now some of you English people are like, yes, he's speaking tongues here. Okay. So please, the Afrikaans guys, if you have no clue what the hell I'm talking about, just go Google Translate, please. So in other words, the probability of A and B, why am I going or? Sorry, I'm still on holiday, is 0. What would that mean for a Venn diagram? There's no intersection on a Venn diagram. So if I have to draw a Venn diagram, it's going to look like this. Okay? Everyone good there? And I love, sir, that you use the word ndomiso, that you use the word impossibility, because then the possibility is 0. But I do want to quickly just say something. when you get into the real world, and those of you that are going into engineering, into physics, you will not see this often. That any scientist or engineer would ever use the word it's equal to 0. That would be, it's close to, almost there. You know, it's approximately 0. Because the moment that it is 0, it means it can never happen. Just leaving you up for ambiguous cases here. But mutually exclusive and independent. The important thing, ladies and gentlemen, is I just want to help you fill your toolbox at this moment. Nothing that's an important little thing. Okay? When will they ask this? How will they ask it? That's important. Because if you know how they ask it, you know to look out for it. When will they ask independence? Okay? That's an interesting question. We will ask independence contingency tables. That's why we do contingency tables. Okay? Where else do they love to ask independence? Who has seen independence being asked somewhere else? Say again? In Venn diagrams, maybe a little. Are these two events independent? And then they love to ask us. Where else? With probability sums. What are probability sums? The probability that A or B happens is the probability of A plus the probability of B minus the probability of A and B. Why do they love to ask it here, sir? For mutual exclusivity, that back part is 0. Or for independence, this back part becomes the probability of A times by the probability of B. So they love to ask it because of this back part that could be replaced. So look out for it. Examiners love to ask it because you guys forget about it. Okay? Because it's just a word or just 2 words. That's not that important. Okay. I'm done talking. Let's go to the first example. First question. Now, please understand, I did not make these examples up. They come from exams. I'm going to give you guys 5 minutes. A group of people participated in a trial to test a new headache pill. 50% of the participants received the headache pill. 50% of the participants received the sugar pill. 2/5 of the group received the headache pill were not cured, and 3/10 of the group receiving the sugar pill were cured. 10.1.1 represent the given information on a tree diagram. 10.1.2, let me move my, here we go. 10.1.2, determine the probability that a person chosen at random from the group will not be cured. You've got 5 minutes. There we go. Okay, let me quickly ask you guys this beautiful question. And this question is hopefully very valid. How did we know, or how would we know, that this was a tree diagram sum? if they didn't say 10.1.1 draw a tree diagram. Because that is a very important thing, because they're not always going to tell it. They were just nice. We can see it's a Department of Education. Because I promise you, if this was a IEB question, the 10.1.1 would have been omitted. So how would you have known it is a tree diagram sum if they didn't say it to you? Yes. What's your name? Refilwe. Yes, Refilwe, tell me.
Not only are we given 2 events, we're also given a second trial when we have an event taking place because of that.
Okay. Your first little bit, not only did we know, is the most important part. Not only did we know it is how many events, then you know it's a tree diagram. One event following after another event. Okay, we love this. Okay, I think I'm going to skip forward because I think some of you guys are getting bored here. It's all right. I've got 2 events. I have different polls that are being taken, and I'll push this back a little bit. I've got polls that are being taken, and then I have either you are getting cured or not. And the moment that I have that, 2 events following on one another, we can clearly say it is tree diagram. When do I use a Venn diagram? What do you say, sir? Come on. Yes. Population of people and different choices. Okay? Different options to choose from. Then I use a Venn diagram. When do I use a contingency table? Different populations, different choices, but what am I checking? Say again? Independence, well done. Then you have a very clear idea that you must go towards a contingency table, is the word Venn, or is the word independence. Okay? Everyone all right there? Everyone good? Okay, so let me quickly actually do the sum. Almost forgot to do the sum. Okay? So I'm having a 50-50 split. I have headache pills and I've got sugar pills. 50% and 50%. Then I have being cured or not. I love that some of you guys are using your apostrophes there for saying not cured. If you don't know about that, it's maths because maths is lazy. Okay, we want shorthand for everything. Okay, so 2/5 of the group that received the headache pill were cured. So in other words, 3/5 were not cured. Please, 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 please be very careful of assumed knowledge. They'll tell you it's a 90% chance of rain. Automatically it would be 10% that it's not raining. We're going to do maybe 1 or 2 of those later on. 3/10 of the group receiving the, sorry, this is swapped around. Aha, I am still on holiday mode here. Okay, 3/10 were cured and 7/10 were not cured. Now here comes an interesting question. Are these events independent? Now you guys are very careful. Now you guys are like, oh. Does being cured depend on which pill you take?
On which events independent, like that you appeared or not appeared, is that independent?
Ah, now you are starting to ask the right questions. I love it. Being cured. Is that independent from which pill you are using? Clearly not. Because being cured with this pill, 60%. Being cured with this pill is 30%. So, is it dependent? No. Okay, ladies and gentlemen, I'm messing with you, but I actually want to say something very, very true. You've got to be careful in the world out there. We can just say it's not independent. Being dependent means there's absolutely no chance of independence. Same with a hypothesis. You will never hear that they say we have proven our hypothesis. We will say we haven't disproved it. Or we have disproved it. We can never say in the world out there, and it sounds very silly, but it is the way that we speak. This is not dependent, but it's not independent. If you need more on that, I will break down the semantics to you later on. What is the probability that someone is not cured? So I want to end up there and there. So 50% times by that, times by 2/5. And not cured, 50% times by 7/10. And here comes a little thing again, sir. Words matter. What did I say? He takes this one and that. So the moment you hear the word and, you've got to think of multiply. Multiply. But I could end up there or there. There's a beautiful word there. So when you hear the word and, you know you've got to think about multiply. When you hear the word or different options, you must think of plus. This is very, very, very important for the matric work. Or is plus and is times. There we go, ladies and gentlemen. A nice quick 7-mark sum to warm you guys up. The 3 events. Oh, and just for those of you, because I know some of you guys are getting very anxious because, sir, you didn't finish the sum. 0.55 or 11/20 or 55%. Which one do I prefer? 11/20. Most accurate is always fractions. So I'm going to give you guys 7 minutes, a mark a minute. They should go quickly. Keeping my fingers crossed. Go for it. How many of you are going into physics? Now keep your hands up, please. Axi. Some of you. Anything in the BSc? Number of you. To quickly say this, in this first semester of your, let's say in the first year of your studies, because now they've made it easier for you guys. When I did it, it was a bit more difficult. What we did in 1 semester, they're stretching out into 2 semesters because 60% of students do not make first year maths. That's not my data. That is the university's data. But can I tell you why? Because in 1 year, you are going to do the same amount of maths you've done in grade 11 and 12, and going to have to write about everything. So the most important thing you will ever learn is to eliminate what you don't need. If I look at question number 1, the most important thing is, what do I want to prove? The probability that A and B is 0. Now, what options do I have to do that? Am I going to look at Venn tree or contingency tables? No, so that's out the window. Okay? So all I've got left is basically the probability sum. And I'm hoping that all of you got yes. It is mutually exclusive. Okay? Now we look at 10.2.2. Determine the probability of only C. Now here's a problem. What is the problem? Do we have any formula that works with the probability of only one thing happening? Do you have a formula like that? Because I don't either. Okay? So we can't use formulas. So now we've got to spring back. What other tools do I have? I've got a Venn diagram. And the important thing is, the probability of all of these events happening is 1. The probability of the sample space is 1. So everything in the Venn diagram has to add up to 1. Little bit of assumed knowledge. Please be careful of that assumed knowledge. So if I look at A and B, they can't intersect, they're mutually exclusive. The probability of A or C, now be careful, that is all of these probabilities adding up together, must be 7 or 10, so I'm not going to worry about that one. The probability of A and C happening is 2 over 5. The probability of B and C is a half of this, so that probability in there is 1 over 5. Now I've got to be careful. Remember what you had at the top there. The probability that A happens is 2 over 5. So this is 0. Because there's already a 2 over 5 there. So if I look at the probability of B happening, that's 1/4. So that is going to be 1/4 minus this 1/5. It's 5 over 20. Am I right? I'm feeling like I'm wrong. It's 5%. So it's 5. I'm just going to write 5% here. Okay, 5 over 100, 1 over 20. There we go. Now we've got to kind of look at this. What do I know? I want to calculate that colored in part there. So, 0 plus the 2 over 5 plus the probability of only C happening plus 1 over 5 must be 7 over 10. And now I just solve for C, for this part here. Again, what made me think of Venn diagrams? I had no other choice. Tree diagrams is not going to give me only C. Contingency tables are not going to give me that. It's just for independence. So the only other option I have is Venn diagrams. Ladies and gentlemen, that's going to be your secret to success when you study engineering. It's a secret of success when you study AXI. Is eliminating what you don't need. Secret to making physics work. Eliminate all those millions of formulas you don't need. Now, ladies and gentlemen, I'm going to move on to grade 12 work. Okay, let's quickly just, look at the last question. Determine the probability that the events A, who got the answer for only C? So how much? 1/10. Or how much did you guys get for that only C? 0.1. So 1/10. Okay? So this one is 1/10. If this is not right, I blame you. Okay? Okay. So 1/10. Now the question is, determine the probability that events A, B, or C do not take place. So which part of the Venn diagram is that? It's this outside part. Okay, so the outside part, 5% plus 20%, 40%, so this gives me 25, 65, 75, 25%. I like to work in percentages. So I'm going to give you guys one more grade 11 sum before I move over to the grade 12 sums. There we go. So again, ladies and gentlemen, let's quickly, and I think one of the things that you guys must learn to do, and if there's one thing that I can encourage you to master, is to plan your sum out before you do it. What am I going to use? I'm going to use a tree diagram because I'm talking about players that are fit and players that are not fit. Okay? And then I'm talking about winning and losing. So definitely I'm going to use a tree diagram. Okay? I'm going to use a tree diagram definitely. Okay? So if I look at this, the probability that a certain rugby team has all its players fit is 70%. This kind of feels like South Africa at the moment. Okay, our Springboks are there at the moment. Okay? So the probability that they are fit is 70%. So automatically I'm going to use my implied knowledge. What is the probability that they're not fit? 30%. This is that they are not fit. The probability that they will win the game if everyone is fit is 90%. Okay? When they are not fit, okay, let's just first implied knowledge, not win, 10%. This, again, now our winning and not winning is 45% and 55%. If you got the tree diagram correct, you must pat yourself on the back, because this is arguably the most difficult kind of sums to see. Because you guys just it feels like there's never enough information. If you don't get it right, you know what you've got to work on the next few weeks. Calculate the probability of winning, so there or there. Again, here or there. The probability that they will win a game if all the players are fit. So I'm going to say 70% times that, 63%. 30% times by that is 13.5%. So in total, 76.5%. Am I right? Oh, maths is great when I'm getting into the swing of things. I love it. Okay, please don't ask me why it only counted 2 marks. I think that might have been a mistake on the copy and pasting, because this is not 2 marks. Okay? Everyone all right? Okay. Oh, only 50 minutes left. Ah! Okay. Okay. Now, ladies and gentlemen, okay, I'm going to start having fun. I want 5 volunteers. 5 volunteers. 2 boys and 3 girls. Okay, come up, chap. I knew your hand is going to be up first, okay? Okay, so now I want 3 ladies. 3 ladies. Come on, ladies. We're not going to do anything funny, I promise. We are going to laugh at some of the things, but that's more laughing at me than the people. 3 ladies. Come, ladies, come. 3 ladies. Otherwise, I'm going to start picking. Okay, thank you so much. Okay, so I've got another lady. You've got another 2 ladies. Okay, thank you so much. You can come up. Okay. Come on, one more lady. Okay, there we go. Thank you so much. Thank you so much. Okay. Our Caucasians are a bit shy of coming up here to the front here. Okay? I love the representation. Okay? Okay, thank you so much for volunteering to come up. Okay? Now I hope you brought some clean clothes. Okay? I'm joking. I'm just joking. I'm really joking. Sorry, that's my joke for the day. Okay. Why am I bringing them up? I'm bringing them up because I want to illustrate the 2 different types of grade 12 sums you are going to get. The first type of grade 12 sums you are going to get is like you beautiful people standing here in the front. Okay, you each have different names. Okay, Murishan. Okay, I've got junior. Okay, one day you'll be senior, hopefully. Okay. Hey, those jokes don't stop, hey? Can I have a look? What's your name? Ashley and Refilwe and Boitumelo. Is it boy or bui? Boitumelo. Okay. I love the African names, just want to say. Okay, so what I would like us to get in our minds is that in the matric syllabus, you're going to get two different types of questions. You're going to get questions like these, where the things that you are going to evaluate are all going to be different from one another. So, unique elements, unique objects. Those are the easy ones to work with. Not people, but people are not always easy to work with. So, let's do practical sums. Now, I want you guys to write this down because this is not on the projection. Okay, it's not on here. I'm winging it as we're going along. I'm starting to have fun now. Okay, so let's say you 5 are excited because now you've done the whole day of junior tax. Okay, and you guys are really happy, but you are now tired of the day. So you guys are deciding to go out to, I want to say Hatfield, but I don't think Hatfield has movies anymore. I'm too old. Okay, oh, those days when the movies were still cheap. You want to go to Brooklyn Mall, okay, and you want to go and watch movies. In how many different ways can they sit? Okay, so all of you guys are getting 2 out of 2 for that one. Okay. Why is it 5 factorial? Because they can't repeat. Sure. Okay, they can't repeat. Okay. They are unique. Meaning, let's say he is not such a gentleman as he looks. I know him, he is, but okay. Okay? Except maybe on the rugby field or on the hockey field, there's a different story. Then the niceness goes away. Why 5 factorial? And I'm explaining it again, just please be patient if you are fine with this. If he goes and he looks at the seeds, he's got 5 options to choose from. So he chooses first. Now please remember the important word, and. What does and mean? Okay, so and. Now my young gentleman here, he goes and sits second. So and. He's got how many options to choose from? 4. So we're talking multiply because we're using the word and. Now we get to the ladies. Ashley, how many seats do you have to choose from? 3. So we're going and 3. You? And you? 5 times 4 times 3 times 2 times. So there's our 5 factorial. Again, why can we use factorial? Because they are unique. The moment that it's not unique, whoa the bus, then you've got to start thinking. Okay, now we're going to start having fun. Because this is just our basics. Let's start with 2 different types of questions. You're going to hear me talk about boxes, and you're going to hear me talk about cement. Okay, boxes. So is when we start putting things together. Okay? Cement is when I want someone seated at a certain place. Boxes versus cement. So let's start with boxes. Like you, this is so nice. 2, 3. Okay. In how many different ways can the boys and the girls sit together? Let's start with the easy one. Boys and girls sit together. In how many different ways? Say again?
2 factorial times 2 factorial times 3 factorial.
2 factorial times 2 factorial.
Factorial times 3 factorial.
Where do you get that from?
Because this is a box, and after the ladies is a box as well. So you consider them separately, and then, so that's 2, and after that now, within each box, the boys is 2, and then within the ladies box is 3, so it's 3.
Okay, so let me quickly say in slow-mo. You're 100% right, chap. Okay. So what I would love us to do, okay, and we're going to get moving now quickly, so you're not going to get too bored here. Okay? Where's my blue marker? Okay? I've got 2 boxes, and I love to draw it. The secret to matric maths, draw the sums. I've got 2 boxes. And you guys are going to hear me talk about outside and inside. Let's talk about outside first. The box with the boys, the box with the girls. As if they are solid boxes. In how many different ways can these boxes be rearranged? 2. But now let's talk about the boys. In how many ways can these 2 boys inside the box be rearranged? 2 factorial. What about the girls? 3 factorial. And because we're working with and, it's as simple as multiplying all of these factorial. Okay? But now, we're going to start having fun. The girls are a little bit scared, so the boys need to protect them. Or maybe they're scared of the boys. I don't know. Okay? That's maybe another one, but let's not leave it there. So I want to know what would be the probability of just the girls seated together. Okay, let me give this now to Ashley. What do you say?
Can you elaborate on the question?
So the question is, what is the probability of the girls being seated together?
Oh, so like that's 3 factorial.
Okay, so what are you doing? Are you using boxes or cement? Boxes. Okay, so I'm putting the girls in a box. Nothing sexist about that, just saying, okay? Okay, don't read anything into that. 3 factorial, okay? Times by? Okay, so where do you get the other 3 factorial from?
There's 2 boys, so like that's 2 separate lines.
Yes?
The girls together are aligned in the top.
Aha. So because I've got 3 factorial there, I've got 1, 2, 3 objects that are unique, and again important, that are unique. I'm going to say 3 factorial. So is this answer then 3 factorial times by 3 factorial? So you're saying yes. And McMahon is going, Who agrees with her? Let's see if democracy prevails. Okay, who agrees with her that it's 3 factorial times by 3 factorial? Got 1, 2. So the rest of you hopefully do not agree. I also don't agree. Why not?
It's a probability.
It is a probability. So what must I remember? I've got to divide by if there is no restrictions. I hear a what here in the front. Is that a what from you? Remember, the probability is the number of ways that an event can happen divided by how many options are possible if there is no restriction. So if we say no restrictions, the 5 of them just seated, just all randomly. And am I right that this is what you are saying? 100% right. Okay, now. Okay. This is now where life's going to start becoming interesting. Now, let's do one more with you guys together here at the front, and then I'm going to ask you guys if you can go and sit and take notes. Okay. So, Refilwe, you've now started to eye Junior there. Okay, so now you go and you sit beforehand. Okay. And you start asking yourself the question, if we just randomly, what is the probability that Refilwe sits next to Junior? Because you really, really like him. You know, you've watched him, the hair is fly, the shoes are drip, you know. I'm way too old for all of this terminology, I just have to say. My little girl yesterday, she's like, oh, Daddy, she's 10 years old, apple of my eye, but man, she's like, no, Daddy, those shoes just make the person look drip. I'm like, oh, man, I'm way too old for all of this. Okay, Junior, are you and Refilwe, who's going to answer this question? Junior, okay. Yeah. Either she has a lot of faith in you, my man, or she wants to throw you under the bus. You're going to have to sort that one out. I'm not sure. Okay? I don't know. I can't read into her mind. Okay? Okay, so where does the 2... Let's start with the 4 factorial. Where does the 4 factorial come from? Oh, it's difficult, hey? All of a sudden, it's not that easy to be a teacher, right? Woo! Okay, so where does the 4 factorial come from, Junior? Or hopefully not from him, because now you're in trouble because you're going to have to explain here. Okay?
Okay, so since me and Rafil were sitting next to each other, there's a box, that's the one box.
Okay?
Since we still have to account for Mauritian, and we have to account for Guatemala and Ashley, then that's the box is 1, and then everyone else's spaces is 3.
So this becomes 4 factorial. Loving it? Okay, and the 2 factorial?
It's just because I could sit first, or Rafil could sit first, or she could sit first, and I'm second.
Well done. Thank you guys for being my guinea pigs. No clean clothes needed, hopefully. Thank you guys. You can go and have a seat. Thank you so much. Yes?
So how will you do this one? What is the probability of Mo and Julian sitting next to each other?
Aha! Thank you so much. It's like, we're reading each other's mind here. So you are asking me, what is the probability that Junior and Mo, I like that, Mo, does not sit together? Okay? Junior, what's my answer there?
So I just sat down, I still need to.
He got completely side-railed having to sit next to a girl. No, I'm joking. Sorry, I'm a horrible human being. Okay, just having fun. Okay, whoever said you can't have fun in maths? Okay. Okay, so let's have a look here in the middle. You guys are way too quiet. Oh, I've got a lovely lady in the front. So what do you say?
I say you say 1 minus the probability of Junior and Mo sitting together.
Well done. What's your name?
Elizabeth.
Elizabeth. Well done. This is a very important one because not sitting together is always 1 minus the probability of them sitting together. Now that you can hopefully handle. Okay? So let me put a spin on this one for you. I'm going to ask 2 questions, and the 2 questions I'm asking on purpose. Okay? They might seem the same, but they're different. Okay? And this is one of the reasons why I'm a national examiner from next year. Okay? Because I love to ask questions that seem the same, but there's a bit of a bite in the tail there. The first question is, what is the probability that the boys will sit at the ends? They're being real gentlemen. Ladies, you go in, you sit, we will protect you. Okay? The second question that I want to ask, and I'm sorry my blue pen is running out of ink here. I will do my utmost to write as hard as possible while I quickly go and fetch one. What is the probability that the girls will not sit? Okay, no, let's not do that. The probability that the girls will sit at the ends. Now, please understand that those 2 probabilities are not the same. So I'm giving you guys 3 or 4 minutes. Go for it. Just going to quickly go and fetch another pen here. So for those of you that can't see there because it is really light, the first question is the probability that the boys will sit on the ends. The second question is the probability that the girls will sit at the ends. And it's not the same. So the second question is the probability that the girls will sit at the end. That's the second question. Okay. Now, ladies and gentlemen, this is a typical cement type sum. Because I'm cementing the first one, I'm cementing this, the last one, and I am just leaving the rest open for interpretation, okay? So, and unfortunately, I'm seeing this because you guys get so used to factorial that the moment you want to write something down, you just put an exclamation at the back. There's 3 options. Let me write 3 factorial. Okay, whoa. Let's look at the first one. The first one. The probability of boys at the end. So let's go and set the boys first. So let's again say, Junior, you are up first. How many options do you have to choose from? I've got 2 to choose from. Now, my friend that side has got 1 because you made the first choice. Please, this is not 2 factorial times by 1 factorial. It's just 2 times by 1. Then in the middle, does it matter? Does it matter whether they said boy, girl, or boy, girl, or girl, boy? Well, it matters, but the gender doesn't matter, or the sex doesn't matter. It's just 3 factorial. And there's my answer. 2 times 3 factorial, because it's 3 to 1, and then times by 1. All, of course, divided by 5 factorial. Let's quickly look at the second one, ladies and gentlemen. The probability that now the girls are seated at the end. What makes it different? I've got 3 girls. So therefore, the first seat doesn't just have 2 options to choose from. There's actually 3 to choose from. 1 girl goes and sits here. Now I still have 2 left there. And then in the middle, I've got 3 factorial. Be very careful. They love to ask these fine little nuances, these funky little small difference questions that constantly makes you think, oh, but it's the same. Yes? Yes.
So, with this second question with the girls at the end, did you say that the girls went to go sit first and then they dispersed? Because I'm wondering if the girl goes to sit and then 3 seats are filled, and then there's maybe the possibility of only 1 girl being left.
Okay, I hear what you're saying, but let me quickly assist you by just clearing up the clutter. Always look at the cement first. Because those are the things that's going to restrict. Those are where the restrictions are lying. The same thing happens with codes. Okay, if they say the probability of a code being even, what will restrict it to being even? The last number. That will be the first one you look at. And only once you've looked at it, then you go and look at what's happening in the rest. So with cement sums, always look at the restrictions first. Okay. That will definitely clear up a lot of confusion. Because the problem with probability is, sir, the more you think about a sum, the more confused you get. But what if this? But what if that? Don't always think too hard. Okay, let's go and do 1 or 2 sums. Okay, quickly do this question 12.1 for me. I just want to quickly give my voice a break here. Okay, I know that I caught some of you out because for the last one, some of you might get a negative answer. And that's a bit of a problem. If you get a negative answer, I really hope that sent off some alarm bells in your mind. Okay? I think it sent out a few alarm bells here in the front, am I right? getting a negative answer. Let's look at the first one. In how many different ways, okay, don't know why that is happening, okay, in how many ways can they sit in alphabetical order? One. There's only one option, okay, because it's going to be first Corey, then Emily, Clara, Lizzie, Penny, then Shirley. Okay, unless you want to be really funny and say, but what if it is reverse alphabetical? No, no, no. No, no, no. There's only one way. Okay? But the second one, what makes it different from what we did previously? It's different because I'm not working with probabilities. I'm working with a number of ways. Now what? So first of all, I'm sitting with a bit of a problem here because I'm again talking about not sitting next to one another. I don't like to work with that. Am I right, sir? I want to sit with them together. So let's look at the box. So if I look at this box, there they are together. How many are there? 1, 2, 3, 4, 5, 6, 7. Okay? So that means 1, 2, 3, 4, 5, 6, 7. If I look at this, them sitting together, outside the box, 6 factorial. Inside the box, 2 factorial. But our problem is that we're not asking them for seating together. We're asking them for not seating together, but the problem is they are not asking for probabilities. You're asking for number of ways. So in other words, it becomes this. 7 factorial minus 2 factorial times by 6 factorial. Ah, thank you so much, sir. I love it, and don't ever lose the Marawai. I love it, Marawai. Why do you say that, sir? How many options were there if there was no restrictions? Remember, there are 7 people. Are they unique? Hopefully. Okay, they are unique. So, in how many ways if there was no restrictions? That's the total number of ways. Okay? But I want to know, of those 7 factorial ways, now I want to exclude them seating together. So I say, how many will there be in total minus them actually sitting together? That will give me all of the ways that they are not seated together. The 6, because I've got one box and 5 different goals. So the box with the 5 goals is 6 factorial. And then inside the box is 2 factorial. You're good. Okay? It's a bit of something to work on, hey? Okay? So remember, when you're working with probabilities, it's 1 minus the probability that they sit together. But when we're working with a number of ways, it is n factorial minus them sitting together. So this is n factorial minus the number of ways of them seated together. You're with me? So be careful of that 1 minus. That 1 minus is with probabilities, not with number of ways. So kind of be careful. That was what they were going for as an examiner. To catch people out going 1 minus. Ladies and gentlemen, this brings me to a very important little thing. Mark allocation. This thing is worth 3 marks. Which means, the moment I start writing more than 4 or 5 lines, I've got to start re-evaluating. Am I going on the right path? Okay? Always tell the story of one of my most amazing students. She was fantastic, the hardest working girl that I've ever had the privilege of working with. But she couldn't get more than 70% for maths. Because she would see a sum, run head first into the sum, scratch out a whole page worth of work, try the sum over again, scratch out another full page, try again, and then she still get 3 out of 5. Because she worked hard, but she didn't think through the sum. That, ladies and gentlemen, is what we're going to look at tomorrow. Tomorrow we're not going to do work like this. Tomorrow we are going to look at how do I approach a maths exam. Because that's more important than just doing it. Okay, not more important, but just as important. So, let's have a look at this next sum. But don't do it. Pens down. Down. Let's quickly stop for a moment. What makes this sum different from previously? Yes. Don't worry, I can listen.
We given a word that has duplicates, if I may say, duplicated letters.
Okay. Can I assume that the A and the A is the same? Yes. There's the difference. We are not talking about unique elements anymore. If I say A and A and A, no matter how I switch it, it's the same thing. There's your big difference, ladies and gentlemen. So this sum you cannot just apply as previously. Now you've got to think about removing duplicates because you've got non-unique elements. Okay? Or you've got unique elements. Sorry about that. So, 12 marks. I am giving you. Okay. Let's do 8 minutes to do A and B for me. Okay, ladies and gentlemen, if you ever want to know whether you really know your stuff, try and teach someone. You'll very quickly be humbled. Okay? The worst mistake I ever did was asking a bunch of grade 10s to explain their maths in English. Worst mistake ever. The guys who usually get 95 got 60s. Okay? Because how do I explain it? The reason why is because whether I say A, or A, and I swap the A's around, does that give me a new option? No. So I've got to remove them from the number of ways. The 12 factorial would be if they are all unique. But I've got to remove those options if they repeat. Now, we get to the fun stuff. If you want to group all the vowels together, so now I'm starting with a box. So inside the box, and please draw the sum. I've got A, I, and E. And then I've got M and M, And I've got all the rest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to go this way. So if I look at the box with the other stuff as if they are unique, I'm going to have 8 factorial different options. But I've got a bit of a problem with that 8 factorial. I've got 2 M's. Why is M and M always giving us a problem? Okay? 2 factorial. But now I've also got to be careful of inside the box. Because inside the box, I do have 5 options, but I've got repetitions. So I've also got to divide by 3 factorial. Be careful of that one, because there's repetitions in the box. Now, so the answer is going to be that multiplied by that. Are they asking me for probabilities? No. So I'm going to leave it as is. The box and cement thing has helped me understand this stuff so much easier. Number 1. Number 2. And for this reason, I'm going to please just give you a bit of warning. Some of you might have heard to my gent there, I used the word Khan Academy. You guys will all know them, hopefully. Fantastic content. But don't go and Google statistics and probability at the Khan Academy. Because within the first 5 minutes, they're already going to go to university level. They're going to start using things like permutations and combinations left and right, and that is not in your curriculum. So please don't. Rather go and watch videos made by South African content creators. Myself. Okay. Nah, just joking. But you can go and watch my videos, isn't it? They're not too bad. Okay. Let me be humble. I'm trying. Now we get to question C. Question C again is one of those questions where if you are going to say just times by 2, you're going to fall into a trap. There are different options. Do you agree with me, sir? So I know I'm going to have to use plus something. So what are my 2 options for C? Calculate the probability that the word would start and end with the same one. So what are my 2 options? Now I'm using cement. What are my 2 options? M and M, or A and A. Now you've got to kind of be careful. Does it matter which M I use there? No. So that is one option, and that is one option. All that is going to matter is what is left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, sorry. It's just going to matter what happens in the middle. Be careful. Same with the A and the A. But the difference is this one will have only 2 things that repeat, but this one will have 3 things that repeat because there'll be 3 M's left. But it's still going to be 1 and 1, simply because whether I say A or A, it doesn't matter. That is the difference when you're working with non-unique elements. Be careful, ladies and gents. So when you approach a sum like this, always the first thing you've got to say is, what am I working with? Unique or non-unique? And from there, you have to then go and draw the sum using either boxes or cement. Our 2 hours are up. Believe it or not. Okay. So ladies and gentlemen, I gave you a beautiful pack of questions where if you are bored tonight and you are longing for home, okay, there are some absolutely gorgeous questions, especially the last questions that I took from IEB papers. Absolutely gorgeous. There's one with a dice, and there's one even with the length, a regular 6-sided dice, and then we're talking about areas and perimeters and stuff. Enjoy. Okay? Tomorrow, for those of you that want to, okay, I'll maybe stick around afterwards or so, and I'll do some of those on the board for those of you that are interested. But also, ladies and gents, I encourage you to go through this booklet of mine. I'm very proud of it. It's about 15 years in the making, and I'm still updating it regularly. Okay, if you want to take it and make photocopies for your friends, go for it. Okay, I really don't care. Spread it as far and wide as you want to. Okay? But ladies and gentlemen, take a 15-minute break. And then you're going to come back, and then you're going to have one of the most amazing physical sciences teachers that I've ever had the privilege of meeting, Miss Natasha Barton. Okay? That's going to do a 2-hour session with you guys. So have a beautiful day. And I'm looking forward to seeing you guys tomorrow after lunch. Keep well. Cheers.